Hi, good evening, everyone. So it's our third CNCF meetup today, and we are with Emre. I know him from several meetups.
So it's our third
and
CNCF
let
meetup
me.
today, and we are with.
Okay, there's a. Sorry for that, and welcome Emre again. So thank you for your participation, and
Thank you.
we are eager to hear about more CNCF topics. And we know there has been like several new projects which has been included to CNCF, and obviously service mesh is one of the hot topic, together with the capabilities of and functions of Envoy. So it's also interesting for me as well to be able to follow this meetup. And maybe any comments on your side, Emre, before beginning? How you see the evaluation of service mesh? Because as you know, there has been different type of tools, not just one, but it's been converging to somewhere. But what's your main maybe comments on service mesh?
Dorian, thank you for inviting me before everything. So yeah, like you said, service mesh is evolving very quickly, and there are competitors like Istio and Linkerd. They are de facto standards in the service mesh side, but also Kubernetes start to write an interface for those service meshes, and I think in the next years there will be a structure for whole service meshes for which wants to be run on Kubernetes, and they will probably try to strict about that rules. And I'm also quite new in this area. For 1.5 years, I'm using Istio. I'm still see myself as a newbie because 1 year is not really enough for anything in tech area. I'm trying to explain my experiences in this talk, and I hope you will like it.
Thank you, really appreciate for attendance. So our also community has been interested a lot with CNCF technologies, and as you know, almost all of the projects nowadays workloads are being converging to Kubernetes. So thank you again for your participation. I know what you are doing, so it's a great pleasure to have you here. And now you can share your screen if you wish. I can add it to stream. So
okay, I will start sharing my screen and entire stream.
And just for the audience, if you have any questions, don't hesitate to write to the chat window, guys, from YouTube, and I will try to warn Emre if he doesn't see. So I also edit your screen.
Can you see my screen?
Yes.
And I have two screen, and they are just colliding right now. Okay. Okay, I'm following the stream from my tablet, and okay, I can see myself. Now, actually, I will try to explain how Istio service mesh uses Envoy under the hood. But before diving into that, I want to explain what is a service mesh, what it provides us, what it brings with itself, and how the Istio works. Before everything, I will talk. I want to draw an architecture of Istio. When you install an Istio into your cluster, what it looks like and what it brings with itself. Let's say this is a Kubernetes node, and there are pods as well. When we install an Istio into our clusters, it will bring its own components like Istio ingress gateways, egress gateways, Istio injectors, and one of the most important thing is, I think, Istio ingress gateways and Istio injectors. Also, let me draw it. Istio ingress gateway. So this component handles the incoming external requests, and the Istio injector handles about the injecting sidecars. Istio injector. we are start to hear the sidecar pattern, like ambassador, proxy, whatever other patterns. This topic is explained under the multi-container pod design pattern. The sidecar patterns are quite new design pattern for container world. This means when you run a pod, commonly we run only one container inside that pod, but it's not a rule. What I mean is you can run several containers in a pod like this. You have a pod, and there's a first container, your application container, and there are sidecars. What I mean by sidecar is like what Istio injects into your pod. First of all, Istio injects an init container into your pod, and this container starts before all of your containers, because this is an init container, and I say it Istio init container. This container overrides all of your IP tables rules and redirects all of the incoming pod requests into Istio sidecar proxy container. And I will draw it like that. Istio proxy container. This Istio proxy container contains two processes when you execute into it, and you will face with one of the processes is Istio pilot process, and other is Envoy Proxy. Other one is Envoy Proxy. So when you install an Istio, the overall view is like that. You have a Istio namespace. There are a couple of components, and when you run a pod inside a namespace, when you label that namespace with Istio injection enabled, Istio injects several containers into your pod. This is a multi-container pod, and like I said, Istio init container overrides IP tables, and all of your incoming requests get through from that Istio proxy container. In this way, you can manipulate all of your network because all the incoming requests just gets through Envoy Proxy. When you in this way, you can manipulate all of your network requests because it gets through another proxy before just arriving your application. But what it brings with itself, let's take a look at that. A service mesh tries to decouple several of capabilities from your application. Like when you want to mirror your traffic, mirror your incoming traffic, if you don't use any networking application, any service mesh, or any proxy in front of your application, you need to write that mirroring code inside your application container, or you just need to find another way to solve this requirement, to provide a solution for this requirement. And another thing is when you want to return any static response body for an error situation, you need to handle this in your application code. But when you use a service mesh, especially when you use a proxy in front of your container, you can do all of this networking stuff in that application. In this way, in this situation, it is Envoy. Other situations, like when you want to enable an MTLS, secure communication between your pods, you can do this with your sidecar proxy, because all of your networks just flows from that sidecar proxies. What I mean is, let's say your application runs a plain text HTTP server, doesn't have any self-signed or any SSL certificate. When you want to make all the network communication in a secure way, you can do this with Istio. And what I mean Istio here is actually Envoy Proxy. You can do this in Envoy Proxy, like just writing a destination rule, and destination rule TLS enabled. This is a custom resource written by Istio. When you write something like that, this is not the exact custom resource. When you write something like you can manipulate all the network and force the TLS communication. Your application starts a connection to Envoy because you overwrite the IP tables rules. Your request just goes through there. The plain text communication starts with Envoy, and Istio installs self-signed certificates into the clusters. There are certificate secrets in Istio namespace, and it turns that plain text request to MTLS or TLS request. The other node also contains the same certificate. Because of that, this Envoy can turn that MTLS request into a plain text. In this way, you can secure your microservices simply just by writing destination rule, which is a custom resource. So, how those custom resources affects Envoy? Actually, this talk focuses on that side of Envoy and Istio. I'm not explain all of the Istio features or Envoy features, but we will focus on those configurations, how that configurations works. Like I said, Istio proxy container contains two processes. One is pilot, and other one is Envoy. What pilot does is actually this process listens all of the custom resources created by Istio, like destination rules or virtual services, and configures and take that configurations and turns it into some config which understandable by Envoy, and it configures the Envoy proxy in a dynamical way. How that works? How is that works? When you write a custom resource, pilot agents listens those configurations and pushes that to Envoy. But what tool provides that pushing mechanism? It's actually called by XDS feature of Envoy XDS. Let's take a look at that XDS features of Envoy. There are several discovery services provided by Envoy, like endpoint discovery service, cluster discovery service, secret discovery service, and this X means that all of it, any of the discovery service can be take that X. I just searching for an article, Envoy XDS and rest of it. Also, those XDS services can be manipulated in a way Istio Envoy provide us. And control plane. I wrote a keyword, control plane. There are control planes and data planes. It's a concept. Also, Istio has that concept. This is data plane. This component is named as data plane, and this component is named as control plane. So with Go control plane, we can manipulate all of the Envoy configuration in a dynamical way. We wrote a gRPC server. We tell Envoy that we have a XDS service in that gRPC address, and we start with Envoy. We start an Envoy with that configuration, and all of the configuration goes through that gRPC server. You can write YAML configurations for Envoy, but you can also use that control plane like Istio does. So there are articles about XDS service, and you can make various configurations with that. We just focus to Go control plane, and we will. I wrote an API, Go API. We register that API into. We will register that API into Envoy, and we will make and basic and not basic authentication, actually reback authentication. There are filters in Envoy. I have an article about that. Envoy WASM filter. Let's take a request flow of Envoy. There will be an image. I think it is loading. Okay, it's still loading. Why I can see that? I just want to show you guys a very little overview of an HTTP request flow. There are filters provided by Envoy. Okay. When we want to proxy request in Envoy, we just create a listener, which is actually opens a port from Envoy side and accepts incoming requests. And we write filters like HTTP filters, WASM filters, other reback filters. All of those filters goes through a chain. We built a filter chain, and Envoy executes that filters, then routes request our target service. So in this article, I try to explain what is WASM filter and WASM how it works in Envoy. But what I actually want to show you guys, okay, this image. We create a listener on Envoy side. We write our filters, which one of the filters is reback filter. We write a reback filter with Go control plane, push that rules into Envoy, and we will route our request to a service. So let's take our service, and then we will take a look at our Go control plane. Okay, this is Go control plane. Can you guys see my development environment? Is the code clear? Okay, reback builder main. I'm opening my API. My computer quite slow right now. I don't know why. Okay, it's still starting. If you have any questions, you can write it and I can answer that if I know. Still quite slow. I don't know why it's slowing down my IDE. Okay, it's frozen right now. Battery on hold. Okay, this is my API, and there are several endpoints in that. One of that is numbers, which returns several numbers, and other is that test endpoint. Those test endpoint returns a reback access string, and when we see those string, we can understand that we can easily access that, and we will try to put a reback filter in front of this API. We will secure those endpoints. Okay, let's take a look into our Go control plane codes. Oh, it's still frozen. I don't know why. My computer is quite slow right now. I'm trying to close unnecessary tasks. Yeah, it's just moving without. I cannot control my computer right now. Sorry for that. It's still freezing. Okay, I think it's good right now.
Meanwhile, Emre, till you saw that computer, there is a question. If you mind to answer
Yes.
me.
Okay.
Do you mind elaborating how the service discover works? Does it use some sort of DNS solution?
Okay, I understand. Okay, are you asking that for Istio or Kubernetes? I think it's related with Istio, how Istio resolves service addresses.
James asked the question. I think this may not be specific to service mesh, but more like in general. Like maybe James, if you can elaborate more. I think it is
Okay.
more like how DNS works in Kubernetes, right? Oh, okay. He's asking with regards to Istio, how Istio affects.
Like I said, Istio watches a couple of resources. One of that is its own custom resources. It's watched by Pilot. Also, there are Kubernetes resources like services. In Kubernetes, there are a resource specific to Kubernetes service resource. Use those resources and take all of the services. Services marked as Istio injection enabled namespaces. Any service those runs on that namespaces watched by Istio, and Istio returns those service names into a DNS names. Any Kubernetes service names is also a cluster for Envoy, because Istio watches those services and returns and creates an Envoy configuration and pushes those services into a Envoy as a cluster. We can see how that happens if I solve my issue on my computer. Okay, it's done. I think there's different components of Envoy like cluster and endpoints, routes, and secrets. I don't remember what that runtimes is actually, and HTTP listeners. Istio watches all the Kubernetes services and makes clusters for that, like this. It will give a name to that service, like what you put your configuration to Kubernetes. When you make X your service name, Istio takes that and makes it a cluster name for Envoy. and creates endpoints. You know, there's a resource on Kubernetes which name is endpoints and endpoint slices. Those are actually your IP addresses of your pods, and Istio puts that addresses into your cluster configuration on Envoy. I make this example. I hard coded all of my IP addresses, cluster names. But when you make this code with a dynamical way, you actually wrote your custom mini service mesh. If I make those configuration dynamically, I can actually create a service mesh, like Istio does. Okay. This is my main function. We will create a gRPC server. We import all of the necessary packages, which is actually all of them is Go control plane. There are protobuf types, also comes from Go control plane. It's quite hard to do this in this configuration inside the code. You can actually write all of this code statically with YAML configurations like this. You can define your resources in this way. You can write your filters in here as a YAML, but this is not actually. We take a look. We will focus on the dynamically configuration, and I wrote this custom YAML because of we need to tell the Envoy how it gets its own configurations from XDS server. We put a static cluster resource in here, and we name it as a XDS cluster. We put our IP addresses and port values, and this is all of our Envoy configuration. We start an Envoy with this configuration, and it will take its own configuration from those gRPC server. From that gRPC server. Okay. Also, like I said, I wrote an API, and we will need to tell Envoy that, hey, Envoy, there's an API, and you need to route all of the requests to that API. So we need to create a listener for that, and cluster, and if necessary, filters. So I wrote a cluster as a name, which name is example proxy cluster. In here, our upstream host IP address is my localhost IP address, and listener name, route name. So let's take a look at the make cluster function. This is a static configuration actually. There is nothing fancy in here. We have endpoints in here. We put our cluster name and port value here. We will also take a look at the JSON configuration of this Go code. And we also okay, which accepts connections and creates. We also create our routes in here. We have a routing configuration in this connection manager. We say that all of the incoming we want to forward all of the incoming requests into a cluster name, which is how we route requests in Envoy. We make it with route definitions. What I wrote in here is a simple helper function. We create our routing configuration in this way. This is a quite verbose code because you need to write very specific definitions in this way, because all of this configuration is actually protobuf types, comes from Envoy. Let's go back to here. Okay, we have a HTTP filter. I make this command line because I just investigating source code, and there's a feature in Envoy xout filter. You can forward all of your incoming requests into to a external authorization system, and you can make your authorization in that server, and Envoy decides routing or not routing the request according to that external authorization services response codes. And finally, we create a listener. This listener actually opens a socket, opens a port in Envoy and accepts connections from that port. We also give our HTTP listener into here, and we actually create our protobuf, and we put that typed config into here. This is what we can do for routing a request. So let's start our Envoy and check if it routes our request to that. Okay, where is my terminal? Terminals. I don't know why, but my computer is quite slow right now. I don't know why it's happening. Okay, it's still using history grep Envoy. This is my backer run command. Oops, I need to go to path, project path. It's very slow, you can see. The mesh test. Okay, now I can run an Envoy. Wow, backer is not running. Is there any other questions about istio or service meshes? I will close my second screen. Actually, MacBook itself, I will close that MacBook screen. I think it's slowing down.
Yeah, no worries, Emre. This is really usual, as you know. We call it sometimes blue screen curse. So it happens each time you you do any online demos and stuff. And the rule of Murphy, it happens all the time. So that's okay, no worries. Emre, I think we lost your mic. We cannot hear you now. Somehow, when you change your screen configuration, maybe you have changed your mic settings, maybe.
Can you hear me right now?
Yes, that was good. That was okay.
Yes. Okay, thank you. I'm resharing my screen. Okay. Dapr running. Yes, Dapr running. Okay, I'm finally starting my Envoy. And while starting, I explain direct codes. Okay, I wrote a HTTP filter for back filtering. I put a helper method in here, make a back filter, and take a look. Let's take a look at that source. So I wrote several rules for securing my endpoints. I'm opening all of code. Okay. In a high view, I actually want to secure connection, secure request to test endpoint. I want to deny if it is not contain a specifier which I want to be here, we there, and those headers are okay. We will create a permission which is quite bad code actually. It's not actually really code. You need to write that complex code for your rebackers, and you create a permission and permission rules, all header matchers, and all of these DOMs together creates your back rules. I want to match get requests, and also I want to deny requests if those requests are not contains.
Aaron, we are having an echo. We are having an echo in your voice. I don't know why, but there are some type of echo that we hear you double sometimes. I don't know if it's happened just me, but
Okay, how can I solve that? Why our echo?
it's like echoing, but
Microphone, speaker, microphone, pro microphone, Zoom, audio device, actually. Echo cancellation actually open, but is that still happening?
kinda. Let's see. Kinda. Just a bit happening, but let's see.
Okay. I have path matcher, and I have a back deny policy. Okay. I wrote a rule which is when you match a HTTP GET request with a path to test path, you run this reback. This takes a look at the headers, search for test header value and test value header value, and generated into a complex reback rule, like I said. We deny all those that doesn't contain that custom heads. So let's take our Envoy, take a look at our Envoy, and we see several errors in warnings here because we start our Envoy, but we don't start control plane. Let's start our Go control. Z. Okay, I just start my control plane here. The mesh test. Go run go. Okay, export. Go. Go module. When I start this XDS server, we will set Envoy successfully connect to our XDS server. Why is that take too long? Okay, our server started. and to see, yes, we see change in our Envoy logs. It says that we add 2 clusters. We update a cluster x-out-g, update or create a cluster name x-out-g cluster, example proxy cluster, which is our API, and we create or update a listener. Okay, this means we can send a request into our Envoy proxy. Our local host. On being 10,000 we. Okay, we see service unavailable HTTP status. Why is that happening? Why we face with that error code? Because test API is not running right now. So let's run our test API. Test API. Go run main.co. Okay, it's starting. Let's send request again. Okay, we faced with the success code, and we see our numbers here. Let's take a request. Let's try to make a request our test endpoint. Okay, we faced with the forbidden HTTP status code. Also, there is a response body which says access denied. This body comes from Envoy. Is that there's a reback rule and access denied. How we solve this? Like I said, we need to put out our clusters here. Test header, test value. Now we face the HTTP status code. Okay, and we see our API responses here. Reback accepted. Okay. Let's take how Envoy dynamically makes a config change. So I'm changing my secure endpoint from test to numbers. Now we are securing endpoint. Like here, we are securing endpoint. I change into that endpoint and we also set snapshots cache for that, and we run our caches. We need to increase that version. I increased version number, and I need to close and reopen my Google plane because of, like I said, my code is hard coded. I'm not taking any external configuration dynamically. I'm just writing those configuration into a hard code way. Now I'm closing my server, but I'm not touching Envoy Proxy. I'm rerunning my XTS server. In a production, when you write a service mesh, you don't hard close and restart it. You just listen some resources like Envoy listens its virtual server or destination rule custom resource. If I wrote something like that, it will become my demo become a little service mesh. I'm just rerun my server, and we saw here there's a update listener and cluster update logs. Let's request to our endpoint. Let's make a request our endpoint. Now I'm sending a request to test endpoint, which is secured by Envoy just 2 minutes ago. We can access that endpoint without sending a security header, but we access that numbers endpoint. No, now we cannot access the numbers endpoint without sending those reback headers. So let's put that headers here. Test header, test view. Now we can access numbers endpoint too. This actually I want to you guys, you can see that those configuration dynamically sent to Envoy, and you can you'd have to close your servers. Actually, this is just a demo, and this is what istio and some of a gateways or some of service meshes takes our power source from. Envoy provides a very strong, very powerful configuration options to you, and you can configure any of the filters, endpoints, class with that Go control plane or Java control plane. And this is what I actually tell you guys. I hope you find a couple of in my demo, like using cache version and how to write that filter. I pushed codes into my GitHub repository. You can find all of those code that repository. I'm sharing that repository with you. Okay, let's take a look. Envoy control plane. I'm sending it from.
Yeah, if you can write to the chat window. We had some trouble with the voice, Emre. It may happen because of maybe you open or Docker daemon, and it may.
I couldn't hear you exactly. Sorry.
After you open your Docker, maybe it affected your local performance of your laptop. That's the reason. Maybe the voice is echoing, but that's okay. I mean, it's related with your local environment, I guess. But we struggled to hear your voice at the last maybe 10 minutes. It was echoing, but if you can send the link of your GitHub, we will share also with the community, and maybe they may have questions afterwards to maybe get in touch with you later on if you don't mind. Yeah.
Okay. I sent the link my GitHub repository for Go control plane. If there are any questions, I can try to answer that. Is my voice still going?
Oh yeah, it is like echoing. It may be the issue of the hardware, or maybe local resources.
I think it's related with the Logitech Brio camera webcam. Switch my microphone from Mac to webcam. It start make some noise. I think for that. When I open the Mac, it slows down my computer, and I switch to camera. It make echo.
Together with live streaming, maybe it happens. That's okay. I mean, there's nothing to do, I think, for this. Let me also send your GitHub repo for the audience, just in case they may need to get in touch with you. We already sent a tweet and mentioned you, so this will be an option for the audience also to get in touch with you in case they have any questions.
Okay, feel free to get in touch with me if you have any questions.
That's okay. That's fine. Thank you. Thank you very much, Emre, for today. For your
attendance. I'm thanking attendees who attend this talk. For technical issues, I don't expect that or slowing to my PC. Sorry for.
That's okay. Afterwards, we can make a test with you one-to-one, maybe to check your hardware issues. I can try to help you. Maybe we can maybe sort out what is the reason underneath. We can one-to-one test later on.
Oh, that's very good.
Okay. Thank you very much.
Thank you. Have a good day.
So it was the end of the meetup, guys. So we have to stop here. I'm sorry for the technical issues. As core team, we are expanding, and again, if you are interested in our core team, you are welcome. We have in our core team Olga and Adam. Adam recently joined to our core team, so we appreciate all your suggestions, and also regarding the topics. If you want to also be a speaker, you are welcome. And you can get in touch with us through our Twitter account, or also as well from meetup.com.
And for next meetup, we don't have any meetup as the Christmas is upcoming during December. I remember last time we had during December. It's usually you have it's a special time for you, so we don't it's not the best time to have a meetup. But beginning from next year, we are also discussing internally in our core team whether we can move back to face-to-face sessions as we were doing it before pandemic. As the core team, we will check the options regarding the venues that we have done recently. For the ones we remember, as you remember, we were meeting it in central London in different locations. So we will let you know for upcoming meetups in hopefully next year. And if you want to be a speaker, please let us know. And thank you for joining tonight. See you later.